Okay everyone, you've been doing a differentiation for a bit now and you've probably thought along the way, is there some opposite action of differentiation? And the answer is yes, there is the antiderivative where we operate in the opposite way. So when we differentiate, we times the front by the power and then we reduce the power by 1. So anti-differentiation is exactly the opposite. We add 1 to the power and then we divide by that new power. So it is mechanical in the same way as differentiation, but exactly the opposite. And it's denoted by this symbol, this elongated S and the dx, and everything in between those letters is what we are anti-differentiating. So with this one here, we're going to increase the power by 1, so we have x to the power of 4, and we're going to divide by the new power, so divide by 4. And you'll notice here that we've got a plus c at the end, and that's because any number when it's differentiated goes to 0, so there's always a possibility that there was some constant that we don't know about that we have to put in there as well. Now one way to test if your antiderivative is correct is to differentiate it. So if we differentiate this, reduce the power by 1, so we'd have x to the power of 4, x to the power of 3, and then times the front by the new power, and we'll see that those 4's cancel out to leave us with x to the power of 3. So it differentiates back to our original answer, so it makes sense. Now you don't have to write out that working, but just do it in your heads to check that your antiderivative makes sense. Okay, looking at these two examples over here, our first one, we're going to raise the power by 1, so it's going to be x to the power of 3, and we're going to divide by the new power, and we'll just simplify that, so it's going to be 2x to the power of 3 plus c. Okay, it's really easy to forget the plus c, so just make sure you don't. Alright, for the next one, we're going to have negative 2 over 5 x to the power of 4, and then we're dividing by 4, so we can do a times by 4 on the denominator, and then plus c. And so that's going to simplify to negative 2x to the 4 over 20 plus c, where it simplifies to negative x to the 4 over 10 plus c. Okay, so hopefully that illustrates that it's a mechanical process that you don't need to think too much about. Alright, this last example here is just what do you do when you've got a few terms? Well, exactly the same thing, you just take it term by term. So raising the power by 1 and dividing by the new power leaves you with x cubed. Raising the power by 1 and dividing by the new power, 6 divided by 2 is 3. And then raising the power by 1, we're going to have negative 5 times x to the power of 1, and then just remember our plus c at the end. So yes, it is a mechanical process, but you do need to practice it to become fluent at it, and so you'll do that on exercise 22.01 on page 321. Thank you.